Okay, so till now we have understood the basic concept of arithmetic progressions, that what exactly are arithmetic progressions, the terminology is related to arithmetic progression, that is the first term and the common difference. Now let us see different kinds of arithmetic progression. As you know that to create an arithmetic progression we just require two things. So in order to write an arithmetic progression, we need only two values, that is we need the value of first term, that is A, and we need common difference, that is D. So if I have the first term as A and the common difference as D, my arithmetic progression will be A comma A plus D, that is first term plus common difference, then A plus 2D, by adding D to this second term you will get the third term, and similarly A plus 3D and so on. So this will be my arithmetic progression. If I have first term and common difference, I can very easily write the arithmetic progression. So let us take different examples of first term, common difference, and based on the values of first term and common difference, let us write arithmetic progressions. Okay. So first term is denoted by A, common difference is denoted by small d. You need to remember this. So if I say that the first term of my arithmetic progression is 11 and let us say common difference is 2, or let us say common difference is 12. Okay, let us take it as 12. So what will be my arithmetic progression? An arithmetic progression is written like this: the first term, then first term plus common difference. So the arithmetic progression, if I have first term as 11 and common difference as 12, will be 11 comma you will add 12 to this to get 23, then comma you will add again 12 to this to get 23 plus 12, 35, then again you will add 12 to this term to get 47 and so on. So this will be my arithmetic progression if my first term is 11 and second and common difference is 12. Okay. Now what if I have first term as, let us say, 15 and common difference as minus 2. If my common difference is not a positive number, if it is minus 2, then what will be my arithmetic progression? Again, arithmetic progression, the basic structure, the skeleton of arithmetic progression will remain same. It will not change. Just one thing happen, that if you add minus 2 to this 15, it will get subtracted. Okay. So what you simply need to do is, the first term, let us write it a little. So this is 15 and the common difference is minus 2. So the first term of this arithmetic progression will be 15. Then what about second term? I will add this common difference to 15. So if I add minus 2 to this 15, it will become 13 because it is minus 2. So it will get subtracted from 15. Then what about the third term? You will again add minus 2. Now you are adding minus 2, it means you are subtracting 2. So from 13 you will subtract 2, it will become 11. And if you again subtract 2 or add minus 2, you will get 9 and then so on. So what basically you are doing? You are adding minus 2. Here also you are adding minus 2. Here also you are adding minus 2, and so on. So what is the difference between the first AP and the second AP? You can see that the first AP is continuously increasing. It is increasing from 11, then 23, 35, 47 and 59 and so on. It will go on increasing. But if you observe the second arithmetic progression, you can see since common difference is negative, okay, the common difference is negative, you will find that the arithmetic progression will be continuously decreasing. Okay, this arithmetic progression is decreasing. Okay, third example, if I have first term as let us say minus 4, okay, first term as minus 4 and the common difference as 3. Now what you can see, I have taken first term as a negative value and common difference is 3. So what should happen in this arithmetic progression? Will this be AP an increasing or a decreasing? Let us check this. First term is minus 4 as it is. Then what you will do? You will add 3 to this first term. So minus 4 plus 3 will become minus 1. Then again you will add 3 to this minus 1 and it will become minus 3 plus minus 1 plus 3 will give you 2. After 2 you will again add 3 and you will get 5. Then after 5 again if you add 3 you will get, this is 8 and so on. So what kind of AP is this? Is this AP decreasing or an increasing? You can very clearly see this arithmetic progression is an increasing arithmetic progression. Okay, it is continuously increasing. From minus 4 it is minus 1, then 2, then 5, then 8, then 11, then 14, then 17 and so on. It will go on, it will go till infinity. Okay. So what I can observe is, it do not matter whether my first term is a positive number or a negative number. What matters is my common difference. If common difference is negative, my arithmetic progression will go on decreasing. If common difference is positive, my arithmetic progression will go on increasing. Okay. So this is a basic concept. You can write down this in your notebook also as points to remember, that if D is positive, AP is increasing. If D is negative, AP is decreasing. Okay. Then next example, if I say first term is let us say root 2. Okay. Now root 2 is an irrational number, but it doesn't matter. Why? Because I have told you previously that A and D can be any possible real number. Root 2 is a real number, we can realize root 2, that's why I can take A as root 2. So it is possible. Whether it is irrational, rational, it doesn't matter. So A is root 2, and if let us say common difference is also root 2. If common difference is also root 2, then what will be my arithmetic progression? The first term is root 2. Then you will add root 2 to this root 2, you will get 2 root 2. Okay, you will not get 2. Remember this, root 2 into root 2 is 2, but root 2 plus root 2 will give you 2 root 2. Okay. Then again you will add root 2 and you will get 3 root 2. Then again you will add root 2, you will get 4 root 2 and so on. So what kind of AP is this? This arithmetic progression is also increasing. Why? Because this common difference is positive. Okay. So this is an arithmetic progression. Then next, if I take the first term as let us say 7. Okay, if I take first term as let us say 7 and common difference as minus root 3. If my common difference is minus root 3, then what will be my arithmetic progression? The first term of arithmetic progression will be 7. Then after 7, what will be the second term? you will add minus root 3 to this 7. So what if you add minus root 3 to this 7? If you add minus root 3, you will add this term. So the second term will become 7 minus root 3. Okay, second term will become 7 minus root 3. You cannot write 7 minus root 3 as 4. Okay, you know this, because this is an irrational number, this is a rational number. You cannot add or subtract directly irrational and irrational numbers. Okay, so this is the second term, 7 minus root 3. Then what about third term? Again you will do the same procedure. You will subtract, or I can say you will add minus root 3 to this second term. Second term is 7 minus root 3. So what if I add 7 minus root 3 plus minus root 3? It will become root 3 and minus root 3. So minus root 3 will give you minus 2 root 3. Okay. So the third term of this arithmetic progression will become 7 minus 2 root 3. Okay. So this is the third term. Then what about fourth term? Again you will follow the same procedure. You will add minus root 3 and it will give you 7 minus 3 root 3. Okay. So and from this AP will continue. Now what kind of arithmetic progression it is? It is a decreasing arithmetic progression, because this is minus root 3. This is minus root 3, that's why this is a negative value. That's why this arithmetic progression is a decreasing arithmetic progression. Okay. So these are some common examples of arithmetic progression. You can note this, then we will discuss some questions from the practice sheet based on our understanding of this concept. Okay. Okay, let us now discuss question number 1 from the practice sheet. Question number 1 from the practice sheet, it says for the AP 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2 and so on, write the first term A and the common difference D. Okay. So question number 1, it says there is an AP. The AP given in the question is 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2 and so on. Okay. And for this AP you need to determine first term A and common difference D. Now you know this question is a very basic question. What just you need to understand is, it is given that this is an arithmetic progression. So if this is an arithmetic progression, then the concept next term minus previous term is constant. This equation, this concept should hold for this particular series, this particular arrangement of numbers. Okay. So if I talk about first term, what will be the first term of this AP? The first term will be the term from which AP starts. In this sequence, in this AP we can see 3 by 2. From 3 by 2 this arithmetic progression is starting. So I will say A is equals to 3 by 2. A is equals to 3 by 2 is the first term. And what is the common difference? To check common difference, what you can do, you can subtract first and second term. Okay. Second term is 1 by 2, first term is 3 by 2. Just subtract these two terms. Second term minus first term. Okay. 1 by 2 minus 3 by 2, it will give you minus 2 by 2, that is minus 1. So the common difference D for this arithmetic progression is minus 1. So, and if you want to verify that whether this is an arithmetic progression or not, what you can do, you can take the difference of these two numbers also. So minus 1 by 2 minus of 1 by 2, minus 1 by 2, this is the third term. So third term minus second term, it is again minus 1. Or you can check fourth term minus third term. Fourth term is minus of 3 by 2 and minus third term is minus of 1 by 2. So minus minus 1 by 2. I will write it like this. Okay, this is fourth term, this is third term. So this will give you minus 3 by 2 plus 1 by 2. This will again give you minus 1. So I can clearly see that the common difference, the next term minus previous term, the value of this expression is a constant. It is minus 1 here also, and here also. That's why I can say the common difference for this AP is minus 1. Okay. So this is the solution for first question. It's a very simple question. Now let us move to second question. Second question says, which of the following list of numbers form an AP? And if they form an AP, write the next two terms. So this question says that there are four different list of numbers are given, and we need to determine which of the list represents an arithmetic progression. And if the list represents an arithmetic progression, I need to determine the next two terms of the arithmetic progression. Okay. So let us start, let us solve question number 2. Question number 2 says the first term, the first list of numbers is given as 4, 10, 16 and 22 and so on. Now if I want to check whether this list of numbers is an arithmetic progression or not, what should I do? I should just rely on this identity, on this condition that next term minus previous term is a constant. If in this list next term minus previous term is constant for all the differences, for all the values, then I will say that this is an arithmetic progression. So I can see 4 is the first term of this list, 10 is the second term of this list. It's not an arithmetic progression. I am not saying that this is an AP. That is what we need to determine. So this is the first term of list, second term of list, third term of list, fourth term of list. What I will do? I will subtract second term and first term. I will subtract third term and second term. I will subtract fourth term and third term. Now, do I have one more term? No, I don't have fifth term. So I will restrict my difference, I will restrict my subtraction till this fourth term. Okay, fourth minus third. If I have fifth term also, then I can take fifth minus fourth also. Okay. So now let us check second term minus first term. Second term is 10, first term is 4. So 10 minus 4, which will give you 6. Third term is 16, second term is 10, this will give you 6. Fourth term is 22 and third term is 16, this will again give you 6. So what you can see that the difference of two consecutive terms is a constant, okay, which is equal to 6. It means this is definitely an arithmetic, this is definitely an, this is an arithmetic progression. And if this is an arithmetic progression, what is the common difference? This 6 is the common difference because the constant, the value of this constant is the common difference in this case also in an AP. So I can write common difference D is equals to 6. Okay. So common difference is 6. So for this AP, can I determine the next two terms also? Yes, it's very easy. What you can see, the 22 is the fourth term. So to determine fifth term, what should I do? I should add 6 to this 22. 22 plus 6 will give you 28. So 28 is the next term. And we need to determine one more term after this. So just you can add 6 again to this 28. So 28 plus 6 will give you 34. Okay. So this is an arithmetic progression and the next two terms are 28 and 34. So this is the first part of question number 2. Let us check second part also. Now second part of question number 2. Second part of question number 2 is 1 comma minus 1 comma minus 3 comma minus 5. So 1 comma minus 1 comma minus 3 and comma minus 5 and so on. So this is a list of numbers. Now to determine whether this list is an arithmetic progression or not, I will follow the same procedure. Okay. So first I will write second term minus first term. Second term is minus 1 minus first term is 1. Okay. So this will give you minus 2. Then third term minus second term. Third term is minus 3 minus second term is minus 1. So minus 3 minus of minus 1 will give you plus 1. So minus 3 plus 1 is minus 2. Then fourth term minus third term. Fourth term is minus 5 and minus third term is minus 3. So minus of minus 3, that is plus 3. So minus 5 plus 3 will give you minus 2. So what you can see that the difference between two consecutive terms is constant in this case also, and it is minus 2. So what is the common difference for this particular list? I can say common difference D is equals to minus 2. Okay, D is minus 2. Now if I want to determine the next term after 5, what will be the next term? Simply you will add minus 2 to this minus 5. So minus 5 minus 2 will give you minus 7. So this is the next term, that is the fifth term. And I need to determine one more term. Again I will add minus 2. This time I will add minus 2 to minus 7. So minus 7 minus 2 will give you minus 9. Okay. So the next two terms of this arithmetic progression are minus 7 and minus 9. So this is the solution for the second part of question number 2. Let us solve the third part and fourth part also. The third part of question number 2, the series is given as minus 2 comma 2 comma minus 2 comma 2 comma minus 2 and so on. Now here also what I will going to do, how I will check whether this is an AP or not, I will follow the same procedure. So here also I will write second term minus first term. So this is second term minus first term, then third term minus second term, then fourth term minus third term, then fifth term minus fourth term. Okay. Now second minus first, second term is 2 and minus first term is minus 2. Okay. So 2 minus of minus 2 will give you 4 because 2 plus 2. Then third term is minus 2 and second term is again minus 2. So this is second term is 2. This is 2. So minus 2 and minus 2. This will give you minus 4. Now observe this very carefully. What I have got the difference of first two terms as 4 and the difference of next two terms, that is third and second term, as minus 4. So is this difference constant? Do I need to calculate these values also? No. From here I can see that difference is not constant. The difference is 4, then after it will become minus 4. So I need not to check this difference and this difference, because based on this two values I can interpret that this is not an arithmetic progression. So what I will do, I will not check these two values. I will simply check the first two, and based on this I can say, since difference between consecutive terms is not constant, it implies this list is not an AP. Okay, this implies this list is not an AP, this is not an arithmetic progression. Then the fourth part of question number 2. Fourth part is 1 comma 1 comma 1 comma 2 comma 2 comma 3, 3 and 3 and so on. Now let us check whether this is an arithmetic progression or not. I will subtract second term and first term. Second term is 1, first term is 1, so 1 minus 1 it will give you 0. Then I will subtract third term and second term. Third term is 1, second term is 1, so 1 minus 1 it will give you 0. Then I will subtract fourth term minus third term. Now remember why I am writing fourth and third term also. It's because for the first three terms, for the first two differences, I have got a constant value. I can see this is 0, this is also 0. So I will definitely check the next consecutive terms also. So fourth term minus third term. Fourth term is 2 and third term is 1. So 2 minus 1 will give you 1. Now do I need to calculate further? No, I can see the difference of consecutive term is 1 and here it is 0, so it is not constant. So difference between consecutive term is not constant, hence this is not an AP. This is not an arithmetic progression, okay, because difference is not constant. So this is the solution for question number 2. First you note the solution, then we will continue.